Minimum spanning tree. A spanning tree of a graph is a subgraph that connects all the vertices in the graph without any cycle. A minimum spanning tree of a connected edge-weighted graph is a spanning tree with the minimum possible total weight. To find the minimum spanning tree of a graph, there are two common algorithms. One is Prim's algorithm, another one is Kruskal algorithm. Both the algorithms are greedy algorithms. Greedy means that they make a best choice at each step. Best choice at each step in order to find the overall best solution. Prim's algorithm works by starting a single vertex and then adding edges to MST one at a time. At each step, the algorithm chooses the edge with the smallest weight that connects the vertex in the minimum spanning tree to a vertex that is not in the MST. This algorithm stops when all the vertices in the graph are in the MST. Kruskal algorithm works by sorting all the edges in the graph by weight from the smallest to largest. The algorithm then adds edges to the MST in order starting with the smallest edge. At each step, the algorithm checks to see it adding the edge would create a cycle. If it would, then the edges is not added. The algorithm stops when all of the vertices in the graph are in the MST. See this MCQ, you will get clear with that. Consider the graph as given. Using this graph, you have to generate minimum spanning tree by using the Kruskal algorithm. Weight of this minimum spanning tree is what? Arrange the edges with the weight smallest to largest. For Indian NET examination, each question we can solve. Maximum time limit is 2 minutes or 1.5 minutes we have to set for this each question. The Kruskal algorithm says what? You have to sort all the edges. For this purpose, you need not try and waste your time. You just name the vertices. You have to find the edge with the shortest weight. See here. See, each vertices you just name it. Then only it is easy for you to solve. Without naming it, it is very tough. Which has been included, which has not been covered. These are all the issues you have to face. So you just keep whatever the vertices contained by this diagram, you just keep it. We start with the 1. Wherever we have 1, we have 1 B2C. So you just include the edge here. You consider this edge here and you just put round for here. You have been considered this. Again, where is 1? You just check here. A to B, B to C, then where it is 1 from F to G. You have to go by order. Then only it is easy for you. Then see here where the 1 is available from A to I. So we have drawn these 3 edges with the weight. So we have completed all the ones in the diagram. So you just put tick. We have completed this. Where is the 2 starts? A to F it is available. Then G to H 2. I to B 2. These 2 we cannot consider. Why? If we draw this, then it will form a cycle. If doesn't form any cycle, we supposed to include. Let's we check where the weight is 3. E to F. Let's we consider E to F. But if we drawn, then there the cycle will be created. So we should not consider this. Then 3 we have completed, only one 3 has been considered. Next, let's we move on to 4, that is A to D. So we can consider this 4. Now we have visited all the vertices. How to now check whether we have visited all the node and all the node have some connections. Is it a subgraph of the basic graph? These are all the things we have to evaluate it. First, all the node, that is vertices, has been connected properly. We have been satisfied first condition, and we have covered all the vertices, that also we satisfied. Then the third thing, there is a no cycle. So we obtained the minimum spanning tree. Now we have to calculate the weight of the same. A to I, we have a value 1. I to B2, B to C 1, A to D 4, F to E 3, A to F 2, F to G 1, G to H 2. Calculate the value. The minimum spanning tree weight is 16. The weight of the minimum spanning tree is 16. This is the correct answer.